Superport Designer was used to build and simulate a small-scale MPO production facility with a batch process that can produce 50 million kgs of MPO annually. For use in low and medium-speed diesel engines, MPO manufacture entails modifying PO to reduce and/or remove undesirable components from PO to generate PO with fuel qualities that are similar to those of diesel fuel grade 4D. Viscosity, VVAs, and gums were the key issues that needed to be addressed. Therefore, degumming, neutralizations, and blending were the three main processes used.
In this paper, it has 10 of unit procedure. The first is P&F filtration, second, blending or storage, third, P&F filtration, 4, vessel procedure, 5, P&F filtrations, 6 is heating, 7 is blending or storage, 8 blending or storage, 9 evaporation, and the 10 is blending or storage.
For discussion, filtration, we use P1, P3 and P5 as a filtration to using to plate and flame filter in the MPO production process. They using the filter are used to separate impurities such as particle matter, APM, sludge, soap and phosphatic from the crude JO and the water decam oil. So for the blending or storage, refer to the process step in MPO production where the modified flame oil MPO is the blend with other components such as natural gas condition NGS and store the further use or distribute. So for the visual procedure, also know the V102 visual produce is a step in the process of modifying flame oil to improve its fuel properties for the direct
For
using
PC, the heating procedure in the APO production process involves several steps. First, the crude jatropha oil is heated in S104. Then in S101, the oil is heated again. After that, the oil is sent to P9 for evaporation. The evaporated oil is sent to P10 for blending and storage. Next, for P7, blending and storage refer to the process step in MPO production where the modified plant oil is blended with other components such as natural gas condensate and stored for further use or distribution. For P8, the decanting procedure in MPO production process involves the use of a liquid phase decanter as mentioned in. This decanter is used to separate the neutral oil from any remaining soap or impurity before blending. For P9, the evaporation procedure in the MPO production process involves the use of an evaporator as mentioned in 5. The specific detail of the evaporation procedure such as temperature and operational parameters are not provided in the given information.
For the unit procedure P10, this is the last step in this process, which is blending and storage. This process refers to the process step in MPO production where the modified plant oil MPO is blended with other components such as natural gas condensate NGC and stored for further use or distribution. There are 3 operations involved in this step, which is store, transfer in and transfer out. After the evaporation process, the product was transferred into the blending and storage section through S116 with 50 minutes of duration time. The product then was stored for 60 minutes under adiabatic condition and pressure of 1.013 bar. Lastly, the modified plant oil MPO has reached the criteria and being transferred out from the storage.
Move to the economy analysis on annual operating costs for 2023 price. The table shows of annual operating costs was generated by the software and displays other operating costs, which usually consist of cost of consumables, cost of utilities like heating, cooling and power, The cost of waste treatment and disposal, generally labor-dependent, consists of 55.57%, then the facility-dependent consists of 44.41%, while utilities contribute only 0.03% of the 100% total annual operating cost. The cost of feedstock is found to be the major factor affecting the economic feasibility of the biodiesel production process, and it is found to contribute about 75% until 80% of the total operating cost. The analysis was based on the assumption that a new facility will be constructed for the process with a construction time of months set or in a few years.
Acids, gums, LPM, fuel and sludge make up crude oil. Water-free fatty acids, gums, LPM and sludge must be eliminated since they affect product quality and functioning. Purification requires numerous processes. V101 adds water to crude oil to spread contaminants for water degumming. This improves oil quality. In acid degumming, V102 is treated with a little amount of phosphoric acid to spread gums from oil. This technique cleans up the oil. Next, for neutralize, V102 receives phosphoric acid and sodium hydroxide. This neutralizes free fatty acids into soap-like molecules that may be spreaded, purifying oil. EV101 at high temperature purifies the oil. This procedure purifies the oil. So next, for blending part. In V105, a part of fuel is combined with natural gas condensate, which is NGC, to change its composition and qualities. Blending reduces oil viscosity by 65%, making it smoother and more fluid. For after acid degumming, neutralization and drying, pure oil yields 97%. This method eliminates moisture and volatiles, improving stability and quality.
For equipment utilization chart and Gantt chart, the Gantt chart provides comprehensive information about the simulation data for each operation in every procedure included in the scheduling. This allows for easy modification to operating condition and the ability to recompute the execution plan. Gantt chart represents a detailed timeline of the process step and their duration. Equipment utilization chart displays utilization of different equipment items over time for one or multiple batch. It provides a visual representation of how efficiently the equipment is being utilized throughout the process. Figure 7 shows it's evident that execution of the process step took in 30 hours, resulting in the production of 7 consecutive batches. The overall batch time around 15 hours, but the effective batch time in 2 hours. This indicates that there was significant idle time between consecutive batch, and equipment with the least idle time, known as the time bottleneck equipment, determine the effective batch time. In this case, the reactor V102 was identified as the time bottleneck equipment. Idle time between batch is represented by the white space between bars in figure 6, indicating periods when the equipment was not in use. Understanding the idle times and identify the time bottleneck equipment is crucial for optimization the process and reducing overall batch time.